y'all, let's go ahead and talk about today's stations. So let's go over this first problem really quick. Oh, it's so bright, so bright. Let's make it a little bit not as bright. Okay. So it says the top part of a figure is shown below. The bottom part of the figure is a line of symmetry. So it's saying that this right here is a line of symmetry, this dotted line. Okay. Which of the following shows the bottom part of the figure? So I want to know, if I would have folded this in half, what image would be on the side, on this side of it where the question mark is? What do you think? So would the fin be going this way, like this, or this way? Well, it's going to be going this way, because if I fold this over, then this is going to be coming this way like this. So we've got three options then. This one looks really small, right? This one looks like it's not going to be big enough to, it's not going to be big enough to go from here to here on the dotted line. As you can see, this one goes almost all the way to those arrows. This one does not. This one is a little bit further in. So it can't be C and it can't be D. Let's look at A and B. So A and B, well, I see that this part is like, look how thick that is right there. Do you see how thick that is? Which one looks like the same thickness? A does, right? B looks too thick. It looks like this part is going to be too tall. Taller than this would be. And it has to be exactly the same. So this side can't be taller down this way than this side would be, or else this is not a line of symmetry. So that means that the answer is A. Okay. Oh my gosh, it's so bright. 1 second, y'all. 1 second. Okay, so it says two polygons are shown below. Which statement about these two figures appears to be true? So, hold on. Just too bright. There we go. Okay. A says there are a total of 3 acute angles. Well, let's count the acute angles. Where do you see an acute angle? I see an acute angle right here and one right here. So that's 2. Look, these two are what? Obtuse. This is a right angle. This is a right angle. This is obtuse. This is obtuse, and this is acute, right? So there's 1, 2, 3 acute angles, so that is true. B says there are a total of 5 obtuse angles. Let's count those. 1, 2, 3, 4. Well, that's not true. There are a total of 5 acute angles. Well, we just said that there are 3, so that can't be it. And there are 3 obtuse angles. Well, 1, 2, 3, 4. That's not true either, so the answer has to be A. You have to be able to look at a polygon, y'all, and see what kind of angles it has, okay? And remember that if you can't tell, the best way to do it is to, like, if you're trying to figure out, is this a right angle, line it up with the corner of your paper, just like this. Do you see how that lines up perfectly? That means that it is a right angle, because the corner of your paper is a right angle. However, if I did this right here, let me think of a better way to do it. Do you see how that does not line up? Like, here's the corner of my paper, but this angle goes out farther. That means that it is obtuse, okay? And in this case, I'm trying to think of a way that I can show you this acute. Okay, here we go. So in this case, if I were to line my paper up, do you see how this angle does not come all the way over to the corner? How it's too far in? That means that it is acute. So that's a good way, a good trick that you can use if you can't tell whether an angle is acute, obtuse, or right. Use the corner of your paper. All right, let's look at this one. So it says, what is the measure of angle PXY to the nearest degree? All right, so first of all, just looking at this angle, what kind of angle is this? It is an obtuse angle. I can tell that because of how open it is. All right. Next thing I need to look at is which side am I lined up on. I'm lined up on this side right here. So if I'm lined up on this side, then that means I'm using this 0 right here, which means I'm using those inside numbers. Well, if I'm using the inside numbers and I come all the way this way, I see that it's lined up with 160 degrees. All right, so knowing that this is an obtuse angle, I could have automatically eliminated answer choice F and H, right? Because those are both less than 90, which means that they would be acute. This is for sure greater than 90 because it is an obtuse angle, okay? And then I also could have eliminated J because J says 200. How many degrees is a straight angle equal to? 180, right? If it's equal to 180 degrees, that would go past the line of the protractor. So that can't be it either. So if I were to use even process of elimination, I could have arrived at G. But knowing that I use the 0, whichever side I'm lined up on, that's the 0 that I use. And the 0 depends on whether I'm using the inside or outside numbers. Okay? So the answer is G. All right. Lincoln sorted these figures into 2 groups, Group A and Group B. So which attribute did Lincoln use to sort the figures? So F says Group A has figures with only right angles, while Group B has figures with only obtuse angles. Well, let's look at Group A. Do you see any acute or obtuse angles in here? No, those are all right angles, all right angles. Okay, so this one says that Group B has only obtuse. Well, yeah, these are all obtuse on this figure. These are all obtuse on this figure. Remember, in regular polygons, usually if you have more than 4 sides, actually, like 6 sides or more is a safe bet that they're going to have all obtuse angles. However, over here, we have an obtuse angle here and an obtuse angle. Oops, sorry. I keep thinking that y'all can see my mouse. Okay, I need to get my pencil. Hold on. Okay. So these all have obtuse angles. These all have obtuse angles. This is an obtuse angle, and this is an obtuse angle. However, these are acute angles, so F cannot be true. Okay, let's look at G. Group A has figures with both parallel and perpendicular lines, while Group B has figures with no perpendicular sides. Okay? Well, let's look at Group A. Do you see parallel and perpendicular lines? Yeah. Look, parallel, parallel. I see perpendicular coming together right here. I see perpendicular coming together over here. So it's all parallel and perpendicular. I don't see any intersecting, right? And I know that they're going to be parallel and perpendicular because they're all right angles. If we had any obtuse or acute angles, I would say that we have some intersecting lines, but we don't. So and then it says Group B has figures with no perpendicular sides. Well, do we have any right angles over here? That's how you can tell whether you have perpendicular sides or not. Do we have any right angles? No, we don't. We have all acute and obtuse angles. That means that there are no perpendicular sides over here. So let's keep G in mind. Let's look at H. Group A has figures with only parallel sides. Well, we automatically know that that's not true because we just talked about all the pairs of perpendicular sides, right? Like right here coming together at this corner. So that can't be it. And let's look at J. Group A has figures with only right angles, while Group B has figures with only acute angles. Well, we already talked about the fact that there's obtuse angles here in this figure and here and here. So there's not just acute in that one either. So the answer is G. This one has parallel and perpendicular. This one has no perpendicular. Okay? All right. 8 says quadrilateral BJMC is drawn below. What is the measure of angle CMJ to the nearest degree? Okay. I want you to think about how I told you we would solve this type of problem. Do you remember? You remember? With a strip diagram, maybe? hold on now, I'm trying to turn this light off. There we go. So the way that I would do it is I need to find out what this whole angle is to right here, and then I can figure out, thank you, and then I can figure out what this angle is right here. Because if I find out what this whole part is, right, all the way to this side, including the part that I don't want, because I don't need this part over here. I just need this part in the middle. If I measure this angle, then I can subtract it out from that hole, and all that will be left is this part up here. So let's measure it to right here. So first of all, if I were to start on this side, my 0 is right here on the inside, so I need to use those inside numbers. And if I go all the way this way, I see that it's between 140 and 150. Well, what is halfway between 140 and 150? 145, right? So that's going to be my hole. 145 is my hole. Okay? Now, my part is going to be from 0 right here all the way to this line, which is between 30 and 40. Well, what is between 30 and 40? 35. So what my part that I don't need is 35. The part that will be left after I subtract will be x, which is what I need, right? That's what I'm looking for, that middle area. So let's do 145 minus 35. 5 minus 5, 0, 4 minus 3, 1, 1 minus nothing, 1. So the angle from here to here in this middle part is 110 degrees, which is F. All right? So remember, our strategy for this type of problem where I have an angle in the middle of my protractor is to do a strip diagram and find the whole angle, find this part, and then subtract to find that middle part. Okay? All right, let's look at this one. Which of the following statements is true of the triangle below? Number 1, it has no right angles. 2, it has 2 acute angles. 3, it has 1 pair of perpendicular sides. Okay. Does it have any right angles? Any right angles? No, right? This is a what kind of angle? Obtuse, and these are acute. Well, I know that if this says one obtuse angle, then it's an obtuse triangle, correct? Yeah, it's an obtuse triangle. So if it's an obtuse triangle, I know that it has no right angles, so statement 1 is true. And I know that it has 2 acute angles. It can't have a pair of perpendicular sides because that would mean that it had a right angle, and it does not. So statements 1 and 2 are true, 3 is not. So that means that H is the correct answer here. Okay. All right, let's look up here. So it says, which shows the measure of angle CA? Sorry, I'll knock the peppermints over. It says, which shows the measure of angle CAB to the nearest degree? So let's look at CAB right here. CAB. Well, if I'm looking at an angle with a line B right here, that means that my line is lined up on this side, which means I need to find the 0. The 0 is on the outside set of numbers. So I'm going to use those outside set of numbers and see that this line ends up between 60 and 70, right? If it's between 60 and 70, it is what? How many degrees? 65 degrees, right? Okay, so the answer is C. Let's look at number 2. Which angle is a right angle? Well, let's look at the answer choices. So angle DAE, that's a what kind of angle? That's an acute angle, right? And then the next option is angle CAB. Well, we just said CAB is 65 degrees. So that can't be a right angle because right angle is equal to 90, right? Angle CAD is the only one left, right? Because it's not all the angles, right? Because we just said that F and G are not right angles. So it has to be CAD by process of elimination. We don't even need to do that fancy trick we just did with the strip diagrams. However, if you want to pause the video and do it, you may. So the answer is H. Which shows the measure of angle CAE to the nearest degree? Let's look at angle CAE. Well, if this angle right here is a what kind of angle? Obtuse. And if we're lined up on this side, then that means we're using this 0 right here, which means we're using those inside numbers, right? If we're using those inside numbers and I go all the way this way, I see I'm halfway between 110 and 120. Well, what is halfway between 110 and 120? 115, right? So what's the answer? A. One more. Okay. Macy classifies the figure below as a rhombus. Which of the following statements helps to justify Macy's classification? Well, let's talk about a rhombus real quick. A rhombus has what? What makes rhombi special? Well, they have 4 equal sides, right? They have 2 sets of parallel sides. And then they have 2 acute angles and 2 obtuse angles. Man, y'all have some hiccups today. Sorry. Okay. So it says, which of the following statements helps justify her classification? So it says angle AB is parallel to BC. AB and BC, are those 2 lines parallel? No, they're not, because they come together, right? Parallel lines never touch. They never intersect. AD is perpendicular to BC. Well, I actually don't even need to check that because I know that a rhombus does not have any perpendicular sides because perpendicular means it forms what kind of angles? Right angles, and rhombi do not have right angles, right? A rhombus has 2 acute angles and 2 obtuse angles. Let's look at C. AB is parallel to DC. Here's AB, here's DC. Are those parallel? Yes, they are. Yes, they are. And then again, it can't be D because D says they're perpendicular. We don't have perpendicular sides in a rhombus. So the answer is C. All right, guys, thanks for watching.